Okay. All right, so solving linear systems by graphing. That's what we're doing. So I mentioned this yesterday. This is usually a topic that gets introduced to you in 8th grade. But because of everything that happened this year, you guys didn't get a chance to be introduced to systems of linear equations. Maybe some of you did if you went to a different school besides Rancho, but our timeline there, we did not cover this. So it's basically a system of linear equations. If you have 2 or more, then that's a system, and they have to both be true at the same time for your variables. And we'll look at those definitions. So anyhow, your EQ is how can you find the solution of a system of linear equations by graphing? There's actually 3 methods we're going to learn to solve a system, and the first method is graphing. It's a very visual method. So your learning goals for today, I can determine if an ordered pair is a solution to a system of linear equations. All right, an ordered pair, an x, y, ordered pair like 3, -5. Okay, is that a solution to a system? We can figure that out. I can use a graph to determine if a system of linear equations has no solution, one solution, or infinitely many solutions. So there's 3 possibilities that will happen when you solve a system of equations. There's either one solution and it's specific. There's no solution at all. It doesn't exist. There's like this meme that goes around all the time on social media, like math is great because it gives you hope that every problem has a solution. And I hate that meme because in math, not every problem has a solution. Sometimes it's impossible to get a solution. And that is something that happens with systems. And the last thing is infinitely many, okay? So many solutions, you can't count them because there's just an infinite amount. Last one, I can graph a system of linear equations to determine the solution. Okay, so we are going to be graphing a system with 2 equations and looking to see what the solution is. Is there no solution? Is there one solution? Is there infinitely many? When there's one solution, we can actually determine what that is by an ordered pair, an x, y ordered pair. So here's our vocab for today. System of linear equations, frequently called a linear system. Okay, so system for short means that we're talking about a system of linear equations. Consists of 2 or more linear equations that have the same variables. Okay, the ones that we're going to be working with are going to have 2 equations in the system. All right, so you're going to have 2 equations that have to both be true at the same time for the solution. And it says they have to have the same variables. Most common variables you're going to see are x and y. So ones we are looking at is 2 equations. They go together. It's a system, and they both have x and they both have y. A solution of a system of linear equations is any ordered pair that satisfies all the equations in the system. So if I come up with an x value and a y value, that when I plug those into each of the 2 equations, it makes 2 true equations, that represents a solution to that linear system of equations, to that system. Word you're going to see is coincide, all right, which means to correspond exactly, to be identical, to coincide. We're going to be looking at lines that are graphed that coincide, which means when you graph them, you're graphing one line on top of the other line. They're exactly the same line. And so if you're looking at a picture of 2 lines that are graphed that are the same, you don't even see 2 lines. You just see one line because they're overlapped exactly. Parallel lines show up. Hopefully you remember what those are. That's when you have lines in the same plane, okay, the coordinate plane, that never intersect, okay? They never cross. They're the same distance apart everywhere. Okay, so what does it mean for an ordered pair to be a solution to a system? So right here, kind of checking to see where we are. Okay. Let me make sure my cursor is showing up. It is. Okay. No, it's not. There it goes. Okay. Is 4 comma 1. Okay, this is an ordered pair. 4 comma 1. Is it the solution to, and then we have this kind of little figure here that shows that these two equations go together. Okay, so this is a system of linear equations. It has 1, 2 equations. This first equation has an x and a y. The second equation has an x and a y. So this is a system of linear equations. And the way that you can find out if an ordered pair is a solution, one way is to take that ordered pair and then take each of the 2 equations, and we're going to substitute in the values from this ordered pair. So remember, in an ordered pair, it's always the x value first and then the y value second. So we want to know, does x equal 4 and does y equal 1 work in both equations? And so you can see here for equation 1, let x equal 4, let y equal 1. For equation 2, again, same thing, let x equal 4 and y equal 1. We want to know when we replace the x and the y with 4 and 1, do we get a true statement or not? And that's what it's showing you here. So if I replace the x with 4, we get 4 plus 2 times, replace y with 1, 1. 2 times 1 is 2. 2 plus 4 is 6. Okay? And that was on the right-hand side all along. So because when I finished, I ended up with something that's absolutely true. 6 equals 6 is true. That here we have a thumbs up because, yes, this ordered pair makes a true equation. If I end up with something like 3 equals 1, that's nonsense. And then it fails. Okay, you have to end up with something true. 4 equals 4, 6 equals 6, 100 equals 100. You have to end up with a true statement for it to work. Okay, but it's not enough that it makes one equation true because we're talking about a system of equations. These are buddies. Okay, we have to come over here and make sure it makes this one true as well. So taking the second equation, which is x minus y equals 3, replace the x with 4, replace the y with 1. 4 minus 1, well, that's 3. 3 equals 3. This is a true statement. Again, thumbs up. It works. Since down here it shows you the ordered pair 4, 1 makes both equations true. So it is the solution. Absolutely, it's the solution. That's how to work this out algebraically. Okay, this is using rules of solving equations. This is algebraic. Now, what we're going to look at today as well is graphing. Okay, we know how to graph equations in the coordinate plane. If I have an equation like x plus 2y equals 6, and I want to graph it, well, there's lots of ways to graph an equation. The most common way that I've shown you guys is to rewrite it into slope-intercept form, plot the y-intercept, and then use the slope to plot another point and draw a line. Okay? Another way to graph a line when they're given to you in what this is called standard form. Okay, this is not slope-intercept form. Neither is this one. Both of these equations in the system are in standard form. And if you remember, the thing about standard form is that it's set up to easily find your x and y intercepts. The assignment that you guys had on Monday was on using intercepts, okay? And that's exactly what we could do here to graph these lines. When you want to find the x-intercept, you set y to 0, okay? If this is 0, then x is 6. And then if y is 0, I'm sorry, if x is 0, then y is 3, okay? So you can plot the two intercepts to graph that line. In this picture, it's a little difficult because the point 0, 6 is here. The point, hold on, 0, 6. So if x is 0, y is 3. I see, that got me confused because I'm seeing the 6 right here. This is going by increments of 1. So excuse me. The point 0, 3, that's the y-intercept. The x-intercept is when y is 0 and at 6, so 6, 0. It's off the grid. You wouldn't see it exactly. That's one way to graph a line. You can do the same with x minus y equals 3, or you can even put it in a slope-intercept form and then graph it. So if x is 0, then y is negative 3. So 0, negative 3, there's 1 point. And then if y is 0, then x is 3. So 3, 0, that's your second point. Point is, once you get your lines graphed and you look at that graph, well, they actually intersect in 1 point exactly. And the coordinates of that point are 4, 1. Right? And that's what we had over here, 4, 1. So that's what it means for an ordered pair to be a solution to a system. It is the point of intersection. It's where the two lines cross. And it also makes both equations true. Okay. So I'm going to let you guys try one of these. Okay, so let me explain it to you if it looks a little bit confusing. Okay, so we should be in our pair deck tab. And the question is the ordered pair a solution to the system? Here's our solution. Okay, so, and I did see, you know, one of my students got this far over here. 2 is equal to, see, I'm replacing y with 2. It's equal to negative 2 times x, which is negative 2 minus 2. Okay, so just substituting in and then simplifying all this. Negative 2 times negative 2 is positive 4. 4 minus 2 is 2. 2 equals 2. That's true. And over here, x is negative 2, so replace x with negative 2, plus 2 times, well, y is 2, so 2. Does that equal 2? Well, simplify this hand side now. 2 times 2 is 4. Negative 2 plus 4 is 2, so 2 equals 2. It is, they're both true, which means that this ordered pair is a solution to this system. And if you were to graph it, you would see that the two lines, they actually intersect at the ordered pair, negative 2, positive 2. They intersect in 1 point right here. All right. So this is the next slide. This is a concept map for solution for a linear system of equations. So the definition is that the solution to a linear system satisfies both equations in the system. It has to. It can't be one or the other. It has to be both. Otherwise, it's not a solution. An example of that right below in this box, okay, here is x plus y equals negative 2, x minus y equals negative 2. So we have two equations, both with the same variables. This is a system. And if we graph those lines, this is the picture of their graph. There is one solution where the lines intersect, okay? The place that these two lines intersect is right here. And the ordered pair that represents that point is negative 2, 0. So that is the solution to that system. If we come over here to the facts, the solution is an ordered pair if the two lines intersect at 1 point. There are an infinite number of solutions if the two lines coincide. That was one of our vocab words, coincide. That means they're the same line. They overlap perfectly. Because two lines that overlap intersect everywhere. So everywhere they touch is a solution, all the points. There are no solutions if the two lines have the same slope and have no points in common, all right? So if two lines are parallel, they have the same slope, and they don't touch, there's no point of intersection. So they never cross, there's never a solution. So this is a non-example, which means where there's not a solution. So negative x plus y equals -2, x minus y equals -2. If we look at the graph of those two lines, it turns out they're parallel lines, all right? These never cross. They never intersect, so there is no solution. When you talk about what you have visually, when you take two equations and you graph them, okay, one of three things is going to happen. Your two lines are going to maybe intersect in one spot. Then there would be one solution. If you graph both lines and they turn out to be the same exact line, they coincide with one another, they lay on top and they're exactly the same, then we have an infinite number of solutions. Last possibility, you graph two lines and they turn out to be parallel lines. Okay, one of these three things has to happen every time you have a system of equations. They either intersect once, they are the same line, they intersect everywhere, or they're parallel lines and they intersect nowhere. If they intersect nowhere, then there are zero solutions. Okay, your next slide is based on that. So this is another interactive slide for you. You're going to draw 0, 1, or this sideways looking 8, that's the infinity symbol in the purple box to tell how many solutions are shown in the graphed system of equations. So right now you don't have to actually take each system and graph it. It's done for you. The pink lines are graphed for you. But what does each of those mean? So I want you to tell me which one of those pictures means there are 0 solutions, which one of those pictures means there is one solution, and which one of those pictures tells me there are an infinite amount of solutions. Okay, so go back to your pair depth tab. Everyone. So right here, it looks like there's just one pink line, right? But there's not. There's actually two lines. See, this is this equation and this equation, and they coincide. They intersect everywhere, so there's infinitely many solutions. Here, two pink lines, they never intersect, so there's never a solution, 0 solutions. Here, the two pink lines, they intersect one time at this point, so there is one solution. You should have infinity, 0, 1. Infinity, 0, 1. Okay. So, 12:30, we have 4 minutes left. So I'm just gonna kind of explain this last one, and then I'm gonna give you guys basically like homework. All right? Yeah, that's new, right? It's all homework. So just more homeworky homework. Solve the system by graphing. So if I ask you to solve a system of equations by graphing, and I give you two equations, you need to go through these steps. Step 1, rewrite each equation in slope-intercept form. Okay? You take it. Right now, these are in standard form. If I rewrite them in a slope-intercept form, I get these two equations here. Then graph the lines. And look for a point of intersection. If they intersect one time, like these two do, that point is the solution. These intersect at 2, -2. So the solution is 2, -2. Okay, so you have slide 10 and slide 11. You have 2 problems to do. You can start those right now. You still have 3 minutes left. We are going to solve the system by graphing. This is our system of linear equations. We have two equations, and they are both in the same variables, x and y, x and y. The steps I'm going to follow are step 1, rewrite both equations into slope-intercept form. So I'm going to change the way x plus y equals into -1. So what this is going to turn into, y equals -1x minus 1. All I did was take the x term and subtract it from both sides. For my next equation, 4x minus 2y equals -16. First, it's going to become -2y equals -4x minus 16. And that's just by taking the x term and subtracting it from both sides. I'm not done yet. I'm going to need to divide everything through by -2. So it actually becomes y equals -2x plus 8. Okay, -4 divided by -2 is, I'm sorry, let me change that. It's actually +2, right? When you divide a negative by a negative, you get a positive. And then -16 divided by -2 is +8. So I do have the two equations that I'm going to graph, all right? So just so we can tell which one's which, this one I'll do in a purple color, and then this other one I'll do in a blue color, so you can see where they are. All right, so back with my pencil. My y-intercept for this purple highlighted one is -1. So on my graph, I'm going to go to -1. And then my slope is -1. So I'm going to rise 1 and run 1. Rise 1, run 1. I'm going to keep doing this. Okay, until I have enough points where I could then use the line tool and draw a line through these points. But I actually want to make this line purple and much smaller. Okay. And we put arrows at the end of our line, show that it goes on in both directions. And now I'm going to come over to my next equation, y equals 2x plus 8. So my y-intercept is 8, which is up here. Let's actually do this in blue. And then my slope is +2. So for every 2 units I go up, I go over 1. Or for every 2 units I go down, I go over 1 this way. Once you get a few points, you can then draw your line. Okay. And so, oops. It looks as though I have a point of intersection right here. And so it looks like my answer is maybe -3, +2. But that's something I'm definitely going to want to check, because if that is my solution, then it should make both equations true. And so I'm going to check that now to see if that really is the solution. So we're going to start with x plus y equals -1. So x plus y. I don't know why it's writing it like that. Let me erase that one because that's being kind of silly. No, that's not doing that anymore. X plus y equals -1. And then replacing the x with 2 plus negative 3, does that equal negative 1? That's my question I'm trying to figure out here. The first equation. Is that true? 2 plus negative 3, does that equal negative 1? Well, 2 plus negative 3 is negative 1. So it does work out for the first equation. Awesome. So I know it works here. I could do like a little check mark to show that I checked it. Maybe just to be consistent, I'll do my check mark in the same color. It works. And then I'm going to try the other equation of 4x minus 2y equals negative 16. And then I'm going to replace the x with negative 3. So it'll be 4 times negative 3 minus 2 times our y value is 2. And we want to know, does that equal negative 16? That's what we're trying to figure out. Well, 4 times negative 3 is negative 12. And 2 times 2 is 4, so minus 4 equals negative 16. So does this side equal that side? Negative 12 minus 4, that's the same as negative 12 plus negative 4, which is negative 16. Okay, negative 16 equals negative 16. So on this equation, it also works out. So check mark here. I went back and I checked that it really was the solution. Okay, so this is my answer. And I don't want to use blue. Actually, rather use something different. Nope. Let's use yellow as a highlighter. No, that's not what I wanted to do. Oh, that's interesting. That works. There we go. Our answer is in highlighter, and I'm highlighting with black. Okay, so it works. So this is the solution to this system of equations.